Hello, this is Alan again, continuing my series of videos on the built-in functions to ECL, the Enterprise Control Language. And this one I thought I'd look at graph. It took me a long time to understand graph, and it doesn't really help when the reference manual I've got up here says things like this. The graph function is similar to the loop function, but it executes as though all iterations and processor calls are expanded out, removing any branches that can't be executed and then joined together. Well, that may mean something to you and to compiler writers, but that didn't mean anything to me and lots of others I know, because this graph is really underused. It's quite a useful little beastie and really could be used more. So this is one of the reasons I've got it in the early in my list of videos. So let's get some ECL up and start explaining this graph function to you. Okay, this example really comes into its own when you're searching a data set over with many different attributes or dimensions and with multiple values to each of those dimensions. So in my example here I've got three dimensions, three types of searches, all on this single data set here on a list of holidays, and you really want to search on a list one or more, select one or more tour operators, price ranges and type of holidays, buckets, economy, premium, whatever. So we're just three dimensions here, but you want a selection to be able to, on any one of these dimensions, you'll want to be able to search on a number of criteria, and this is where graph comes into its own here. So in my examples, I've called it 3 times here. There's no filtering at all with the first one, so I'm expecting to retrieve every holiday back, A to M back. Second example, I just am interested in tour operators 1 and 3, not 2, and the bucket codes 3000 and 0. And this one, I don't care about the tour operator, but I am searching just on price of 100 alone and the same set of tour operators. So let's submit that and see what it brings back to us. Okay. So first result, A to M, nothing's been filtered out at all. This one we've just got 1 and 3 and those holiday classes of those that selector we put in. Of course, price is anything there. And in the third example I've got, well, price is restricted to 100, but with the same restriction I had on holiday classes, and I've got no restriction on tour operator. So you can see this yourself here. So let's go through the workings of this little code. How does it achieve that? Well, graph itself takes as its first parameter always the initial input data set we want to search against. The second parameter is the number of iterations you're going to run, and the third parameter is a function. It's not a transform, it's a function. Give it a parameter of set of data sets. That's the syntax for specifying set of data sets to in ECL, and the inevitable counter. Graph doesn't really make much sense without the parameter. It's an optional parameter, but really you have to apply it for graph to make any sense. Right, so the function itself is that set of data sets I was talking about, and the first input data set comes in at index 0 of this set. Now it's the only place I know of in ECL where they index by 0 the first element. Everywhere else the first element of anything is index 1, but in this particular case it's index 0. And so I've myself have constructed a set of data sets from it for each out of each dimension to allow to simplify this code here. It's not actually interesting how you implement some of this. I've just done it for simplicity of showing the code, but it's not an essential components required by graph. But here I'm saying, right, with the first iteration C is going to be 1, so my first data set I'm going to join against is going to be the tour operator dataset, and as you can see, the actual join condition is against tour operator. Then I've got the final return if this filter, in other words tour operator filter, exists, and I want to return the results for join. Otherwise I just want to return the input data set to that iteration. So in fact, as you can see, this 3 is a bit inefficient here. In fact, in production code you'd most probably work out and only supply the filters that you wanted to use, and this n here would become variable, so it would only actually loop around the number of times that you for the filter conditions you actually had. But again, I've kept it simple for the ease of demonstration. So second iteration, C will now be 2. So now the result of the first iteration is at offset 1 in that set of data sets being passed across. Here I've now filtering, because it's 2, I'm going to be using a price filter, and here we are, the price filter at 2. And again, if prices was an empty data set, in other words I wasn't filtering by price, I would just return the result of the first iteration. But if it does exist, then I'll be returning the result of this second join here. And the final iteration, C will be 3. The results of the previous 2 joins will be at offset 2 in this data set. I'm now looking at the third filter in this list of filters here, and the third one is holiday class here, and exactly the same again. So what's returned is what's ever at the top of the graph, the top of the stack at the end of the graph run. And that really is about it. I've uploaded this code to the HPCC forum, and I'll put a link into the description of this video, so you can go away, you can actually grab this code and play around with it yourself. But you can see I've just used 3 dimensions here, but you know, holidays, you've got many dimensions to it. You have you know, things have got a bar, has it got a swimming pool, you know, you can easily get in 20-30 dimensions, and graph really gets into its own when you start talking about those number of dimensions when you're searching. Anyway, I hope that's given some light to graph, a long needed light, and I'll see you in the next video.